All right, so okay, for those of you that are already in the chat listening, I hope you can hear me, right? You can also go ahead to introduce yourself. This is a new series of sessions that we're going to be having on system design, right? And for today, we're going to be working on a very fairly basic topic that you would most times encounter during your system design interviews. What we're going to be looking at is going to be around microservice architecture. All right. So microservice, I'm going to be sharing my screen shortly. So microservice architecture, we are going to be designing a social media platform, around, using microservice architecture primarily. And of course, we're going to cover a lot of sections, from storage to networks, right? Um, yeah, and especially discussing microservice architecture and why using such architecture for this project, of course based on our rationale here, would be a good approach. All right, so I can see, yeah, good evening, Favor Uchechuku, good evening, Idris Adebayo. So yeah, basically this is more of software design, software architecture, and backend related, right? So we're going to be coming up with a quick sketch of what such system would look like, right? Yeah. So of course you can invite your friends. If you have questions, feel free to drop your questions in the chat, and I would yeah, I will take them. All right. So just give me a minute and I'll quickly pull up my screen. While waiting for others to join, I should be expecting a guest in the stage shortly, right? Yeah, so just a few minutes or a few seconds and we're good. Right, you can tell me where you saw the message. If it's from Top Universe, if it's from Techie's Garage, if it's from Better Copper, just let me know where you got the notification. You can also let me know where you're joining from. Where is it, Joshua? Welcome, good evening. Dante Alpha. Okay, Dante Alpha. Is this a favorite? Is that you? Good evening. All right. Sometimes I usually forget. Oh, Idris Adebayo from Top Universe. How are you doing, Idris? Right. Okay. Welcome, Idris. All right. So I'm going to be sharing my screen. I'm going to be leveraging the tool draw.io. If you know that tool, right? So we're going to be using that. Okay. So Top Universe, that is Mon. Okay. I don't think I can pronounce your name. Yeah. Welcome. Good evening. So let me share my screen. All right, so what we're doing is, basically not it's not very beginner friendly, although you will learn a couple of things, right? Especially around how systems actually work, right? But I'll be honest with you, it's not, beginner friendly. If you have questions or if there's something you don't understand, feel free to ask. But it's not going to be like 100%, something I expect you should know if you are a complete beginner. Okay. All right. Hi, Cassie. Good evening. Remember, for those of you that are joining maybe from the 300 Dev Days program, that program is yet to start, starting tomorrow, Monday, right? Um, or I would say the class is starting tomorrow. This is not part of your class, okay? Just to be clear on that, all right? So, yeah, just let me know in the chat if you're having any difficulties, seeing my screen because I am currently sharing my screen already. All right. So I'm going to move the requirements here to a different. Oh, good. All right. So we have Draw.io, right? And right here we have the simple requirement, right? So it's very simple. Design a microservice architecture for a social media platform. Yeah. Good evening, Cassie. Okay. So design a microservice architecture for a social media platform. I think it's ideal to say, most of us that will be watching this probably have a little bit of experience, knowing what, a microservice architecture looks like. But let's just, come up with a little bit of sketch. So let's assume before we start designing this, just for clarity, right? If you have a monolith application, just to give some definitions here, right? So monolith is simply saying, you have you probably have both like your front end, your back end, and your database, everything jumbled together in a single place. So for example, we have, let's say, front end, written in React, right, or React.js, and you have your back end. I would rather put this here. So you have a back end. Maybe your backend is written in it can be C Sharp, it can be Java, it can be TypeScript, or yeah, I mean Ruby on Rails and all that. So you basically have a backend written in C Sharp.net, for example, and then you also have maybe your database you're currently using like Postgres, right, or MongoDB. Okay, so you have Postgres, SQL. All right, so basically when you have every single thing run, together. Um, in a single, maybe in a single server, right? So you have everything in a single server. You are referring to out of us, you have like the front end, mixed into the back end. Maybe you're using like ASP.NET or something. I mean, this is already going to look. So basically, you have a front end application. This is separated, right? Which makes sense. Now, sometimes you might be using like ASP, right? .NET on the front end. Then it might be running together with the back end, of course. But let's just say we're doing this. So you're going to deploy this separately, right? Obviously, you're going to deploy this separately. But now on the back end, you have every single module. So for example, your authentication, right? You have maybe your let's say profile, let's say users. I mean, users can be mixed up with authentication. Maybe you want to do that. Then you have maybe let's say timeline, right? Then let's say posts. Okay. So you see this now. You have this as maybe modules or basically controller, files, your controller modules, right? Sitting within your code base, right? And they all communicate with a single DB, right? This is, of course, which is fine, right? There's nothing wrong with building monolithic applications. As a matter of fact, it's great depending on the use case. Okay, so we have use cases. We have use cases where microservices would excel, right? But this is fine, right? So let's say you're building an application that is, meant to be very large, and you also have a team that is very large. So let's say you have like a team of 30, 40, 50 engineers, 100 engineers, or even going to 200 engineers upwards, and you expect everybody to work on the same, platform, right? Um, I mean, the best thing you should be thinking of is, separating each of these modules, because you obviously would have, new features pop up, right? So you want to have dedicated teams, managing those features. And when you have a particular feature break in production, you don't want that feature to, affect another feature, or right? You don't want a module to affect another module. Okay. So in that case, you might want to now say, okay, on our backend, we have our backend, and then the backend we are currently building maybe the user, right? The user module, or now we can call this the user service. So the user service would have its own, maybe C Sharp API, right? And it would also have its own, maybe you choose to use Postgres, right? So let's say Postgres DB, right? And, it has its own backend basically, okay? So the user service has, its own set of application code and, backend, backend DB, right? And then maybe you're also using a cache, right? So it has its own like, Redis cache and all that. So when you are when you're working on the next service might be um, like the profile service. So you basically have like the profile service with its own C Sharp API, or it can be Ruby, right? It can be Ruby based API. It can be JavaScript, Express.js, and all that. Okay. Yeah. So can we say Django is monolith? Django. So the thing is, it's not really about the framework or the tooling. It's about the way you use it. Okay. So if you use Django to basically set up, let's say the user service, running on Django, right? and then you have like a profile service maybe running with Flask, right? The major thing is you are separating these modules of these several yeah, I mean, you're separating and deploying it. So you're making individual service, deployable on its own, right? So you're isolating it. So basically, the user service will not, will not directly, point into the profile service to pick any file or to pick a function or something. It is separated. It is deployed separately. And if you want to communicate to the profile service, you probably want to be communicating with, sending. You probably want to go the route of, event-driven architecture, or you just want to call over like REST, uh, yeah, maybe like a REST call or something, right? But it's always better if you actually have like a middle service that you can use, maybe something like Kafka, where user service would send a message, right? And then the profile would probably uh, consume, right? Consume. I mean, we'll be able to, but for now, go to cost of today. So I'm going to try to clear on the site. Show them of provide to give just structure would look like. Let's go back again. So if you have like user service, uh, say we're using Java, right? Most of us are familiar with Express.js, very basic, right? So you can actually have the user service, your user service online. You have like the repository, which is like your DB code, right? And we have like some schema files, and you can have like index.js. Middleware, if you use some specific middleware. Then of course, if you also separate your routes, which is fine. So you can basically have a login. You can have sign up, right? You can have verify password. I don't know, verify password, or maybe reset password, right? So yeah. So this this might be the endpoints, right, or the resources, right? Uh, um, then your base URL might be one. This is now service. Let's just call this user service. User service is URL. To drop it a bit, and I just dropped off, and yeah, I'm back. If you can hear me, so I'm going to go ahead and reshare my screen. I'm currently sharing my screen. Please let me know if you can see my screen. Let me know in the chat. Idris, if you're still there. Oh, I can see your message. So Idris, you're saying, okay, now I understand. All right, good. Okay, so I'm still sharing my screen. So this is a profile service, and it would have its own set of resources. So just like maybe you want to get like the profile details, right? It can be the base, right? Then you want to probably do like update profile, right? So you can choose to update profile. So all you have to do, you can simply use the base, right? You can simply stick to the base for some of these things. So more like even to delete, right? So we can basically have like actions like delete, updates, right? And then you can have maybe like fetch that specific profile. I mean, you can do this, right? This is delete. So right here, you can also, you can post to reset password. You can post to sign up, and of course, you can post to login, right? So you just have those various actions, tied, and yeah, you can basically have user. So I believe you understand this, Idris. Is this clear? Is this very clear? Okay, so Monsori is saying the screen isn't clear. Is it much better? Can you see my screen now? Can you see my screen now? Is it better? All right, so I'll be waiting to check. Oh, okay. So Idris said yes, it's very clear. Nice. Okay, so you see, I'm just showing an example of what you might actually want to do. If you want to learn more about how to build stuff like this, of course, we can always have that conversation on Discord. But yeah, so this is what it's going to look like. Now, if we're going to be designing this, this is what I'm going to do. We're going to show like the communication between the user and the service, right, or the servers, that we'll be using. I'm going to focus majorly on two, modules like what I have explained here. Just primarily these two, modules for this example. Ideally, you would have to think about, most of the modules that a social media should have, right? So of course, I'm going to refer to the user module as that specific module that should be able to do things like, authentication, login, sign up. You might choose to have a different, service for authorization, right? Just a service that can perform authorization and authentication, and then you have different modules such as that for your feeds, right? You can have the feeds. It can be a module. So let's just list them out again. So we have the user, we have the profile, we have the feeds. I'll probably stop at this, right? Just these three. Okay, so this is what we're going to do. So first, we're going to have the user trying to access, our we're going to have the user trying to access, our platform. But for now, what I'm going to do is I would rather come up with a container, right? Because I want to put up these items within the container. Of course, the user is going to access this network via a DNS, which is, of course, your domain name service. So let's say you have your DNS such as it can be x.com. So let's just say Twitter, x.com, or having Twitter or X, anything you choose to call it. Let's have that in here. So x.com, right? So this is just an assumption. Um, yep, and drop the size a little bit so we can have enough spacing. All right, so x.com. So you're going to basically access this through the DNS, and of course, we want to have a load balancer that can handle that can manage the traffic that should be coming in here, right? And of course, the load balancer will definitely distribute this across multiple servers, right? So this is what we're going to do. We're going to have this communicate with multiple servers. So let's do it this way. Right now, we can choose to have our, user service. All right. So this is our user service, which definitely has its own DB. So let's just create that flow here. So user service that has its own DB. So that's its own database. Let's just call this DB. Okay. That's fine. Text, so drop that a little bit. Let's drop this as well. All right, so we have this guy with his own DB right here. All right, and yeah, a little bit of styling on the arrow. We just want to show that. Yeah, okay, I think this is fine. So you have this guy with his own DB. This is a service, so let's call this user service. Right, then you also have what is this profile service? So let's have the profile service. All right, and now we have the feed. So let's just call that the feed service as well. Okay, so feed service. Its service. Okay. All right. So yeah, we have communication. We're showing the communication between the DB. Now your DB can be, of course, you would want to choose a DB that actually works for like social network use cases. But for now, we're just trying to focus on the architecture itself. Now, how do these guys actually communicate? Right. That is one thing you have to then consider. What is the mode of communication right across these guys? Do you want to send requests? Do you want to make direct requests, right? So let's see. Okay, so basically, I would prefer to go the route of setting up some sort of broker, right? Or maybe yeah, some sort of event boss. You want to be able to showcase the right way to you know the right way for a service to communicate with another service, right? Now, this is something you really need to think through. If you want to go the route of using PubSub, sort of communication where you have a service running like RabbitMQ or some other some other kind of service. It can be Kafka. I mean, Kafka can actually do the job here. So you know you're basically going to have some sort of using PubSub as well, of course. Yeah. So I think I would just call this a message broker. Okay. So these services would communicate via a message broker. So let's just have a message broker here. So let's see if I can have a broker. If you have something that can be used. Okay, just a very quick. All right, I'm just going to stick to a regular shape. It looks like this. All right, so here we have that message broker. So I'm going to call this a message. Okay, so this would basically, help out with the communication between the services, right? So let's just keep this at the top here with our message broker. So what happens? What happens is that these guys would have to, communicate with the message broker, of course. Okay, let's do it this way. Come on. Don't do that. All right. Okay. So this is all we have. And, the message, the connection lines here would, of course, be bi-directional to show that, we can send messages, but at the same time, get to read from other services. Yeah. So this is just going to be a very simple way to show that instead of having to draw lines, across all the services. Okay. So basically, what we're trying to show is that this guy can simply communicate to this guy through, the same, basically through the same broker, right? So they're all communicating. So let's just reduce this a bit. All right. So now we have that broker, and of course they are all communicating from here. Remember, I said earlier that we want to have a load balancer, right? So that we'll be able to, of course, have a proper communication happening here. If we're going to introduce a load balancer in here, then it means we might have probably different clusters, right? Communicating with this, right? We might have different clusters or different instances, right? Maybe replicated in different regions if you're deploying this on the cloud or something. So just to explain this better to you. So let's say you're communicating with a single um, let's say you're communicating with a single service here, right? If anything should happen to this service, it means your users would not be able to sign in or sign up, right? If this service goes down. But one thing you can do is to then have so we can call this load balancer. right? And this load balancer is basically meant to balance the traffic, across multiple instances. So let's say we have that same user service right here, and we have another user service, okay, right here. So basically, what happens is that this is, connected to both. So depending on, the health of this service, if anything should, yeah, depending on the health of this service, if it goes down, you still have like another service to continue performing the operations that you need to perform. But the idea is if you also have like a large, very high traffic, then the load balancer will be able to manage the or balance the load between both services, right? So this makes sense, okay? And yeah, so what we can now do for this is we need to apply this principle, to our service, right? So remember, we already have a message broker, and you want to ensure that your service is, of course, communicating with a single database, right? You have multiple instances, no doubt, but these multiple instances should be communicating with your database, right? And then you can also choose to have like a replica of a DB, which is fine. So we're going to go from one phase to the other. Just show you what I mean. Let's separate this first. I'm going to come back to this. We need to see I would apply this, principle of, or this, this design where we get to set up a load balancer. So we're going to have this. Let's duplicate it. Let's have our DB, right here. All right. Then we also have this guy right here. So now we have the same application, running on two instances. Maybe you want to deploy this on like EC2 or so, right? You have two EC2 instances, where you deploy these two applications. Okay. Now you can have a replica of this DB, right? Ideally, I wanted to just do this, which you can basically connect the two to the same DB, right? Because I mean they should be using the same database. But in order to even make things better, here we're simply going to have a replica, right? So we're going to have maybe this can be a read replica. This can be like it can just be, or you can actually just have a replica. Let's just call it a DB replica. So let's call it a user DB replica. Maybe that makes more sense. Okay. So user DB replica, and for this I am also going to just have a user DB. Yeah, just like this. Nice. All right. So now we have the user DB and the user DB replica. They both communicate. These guys just like this. Okay. Of course, like this. Great. All right. So remember, always remember that you basically have the message broker, that can manage the communication across, these multiple services. Okay. But when it comes to the entry point, you don't necessarily, you're not getting into this communication. You're not getting in here from the message broker. So we'll come back to the message broker shortly. So now you have this, right? And then you also have you have the profile service. What I'm going to do is simply duplicate this, right? And I'm also going to do the same thing for the feeds service. But I'm just going to use a container to, wrap this properly. All right, so let's get a simple, do this. Okay, so for the line, let's just use the dotted line. All right, so I think this should work. Let's cut and paste in here. Okay, so just to get that clear boundary, all right? So I'm going to do the same thing here. So that is going to be for the profile service, right? All right, so let's go in here for this profile. All right, so also for the DB, we have the profile, of course, the profile DB replica. All right, so one more thing, remember we have the third service. Okay, by the way, our broker. So let's just go ahead and do this for the broker. The broker is going to sit at the bottom here now, right, to aid this communication. So Right. So for this is going to be the feeds DB. This is going to be the feeds DB. This is going to be the feed service. Of course, the feed service. Okay, so I'm going to check the chat now to see if I have any questions before I proceed. I just want to make sure that we're all following, right? So this is our message broker right here that is going to aid the communication, of the individual services. Remember, I told you can of course use something like Kafka. You can use RabbitMQ, but for now, let's just so let me check out the messages in the chat if there's any message in the chat. So I want you to explain the HTTP request for the feeds. Is it a post or get? Okay, so are you presently on VS Studio? No, this is not VS Studio. So you are asking for the feeds. So basically, the feed is going to be like get. Of course, you're just like fetching the requests. You're just fetching those data, and there should be some sort of algorithm that would come up with the feeds, right? There should be some sort of algorithm that would come up with the feeds. So I get what you're asking, because ideally, if you're actually bringing in those feeds, it means they're coming from a DB that might be posts or tweets, right? I don't know what should we call it now that is called X.com. Is it still tweets? Yeah. So basically, the feeds will be coming from the posts. So it can actually be the post service, right? Because the feed is just it's not like you create feeds, right? The feeds is going to contain posts. Okay, so I call it feeds, but what it would contain, would be the posts. And of course, we can choose to call these posts if that would make any. Yeah, I think the naming can actually be very good when you use something that people would understand, right? So yeah, so we can basically, it's called post now. Okay, okay, let's just stick the post then. So it can be the post service and it can be the post DB. So basically, when a user creates a post, right, it will be saved in here. And when we are trying to get the feeds for a particular user, we have an algorithm that will basically look into most of the posts and of course pull down the necessary posts that user actually um, yeah, I mean that the user is following. Okay, so you should be following a user before you see their post. But I don't really know much about the algorithm, so I'm not going to speak to that perspective, right? Um, so we have three major parts here. So the first one is we have the user, we have the profile, we have the post. Some other things we should be looking at when it comes to the social media space can be things like content filter. It can be things like having a CDN, right? Of course, storage. Storage for blob data, image and video. Data, right? We'll definitely write something about that shortly. And yeah, so we can actually have a cache. I did not really add any specific detail to the cache because I was trying to showcase the microservice architecture first. Okay, so the load balancer, when you make a request and you're simply trying to, so yeah, let's just do this. I'm going to put an arrow, right, pointing to this guy, and of course I'm going to use another arrow. This time around, I just want to have a straight arrow pointing like this. Okay, so I'm going to have another arrow pointing to this guy. Can this arrow just remain like this? Okay, so I want this to actually show up on top. Okay, good. So I'm going to have a third one. Let's just put this here. All right. Okay. All right. So we need one more. Let's duplicate this again. Duplicates. All right. So basically, what would happen here is if a request comes in, right? It's going to basically, use the load balancer to make sure that the traffic is balanced across, these services. But then remember, you have the message broker. So for the message broker, I'm trying to check if I can even see like a better. Okay, I'm going to stick to this. All right, so let's stick to this. So the idea is, you have these services, communicating. So I'm just going to use this as yeah, I'm going to basically use this. I'm going to use an arrow from here. Ideally, I mean, the arrow should be coming from the service. I want to communicate with profile service. I'm going to do that, via this. But yeah, I mean, this is fine. So basically, you would have like producers and consumers, right? So this guy can produce and consume. This guy would have like producers, consumers, producers and consumers as well. So this would serve as a channel, for communication across three services, right? Without deciding to just go the route of your regular, synchronous HTTP calls that can fail. I mean, the failure rate would be much more than when you introduce something like this. Okay, so for now, let's just use like the direct arrow thing. So connecting here, it's going to be back and forth. So it's bi-directional here, right? So same with this. Let's just do it this way. Okay, and then the third guy, by the way, this is bi-directional as well. The third guy, so yeah, let's come on. All right, so let's point this here, and of course this guy right here. Okay, so do you have any questions before I proceed? Idris, let me know if you have any question. If you're watching, just let me know if you have any questions before I proceed to the next step. All right. Okay, so let me know if you have any questions so far with what we have currently. Okay, so let me check the chat. Um, okay, so I've not seen any questions yet. All right. Okay, so I'm going to proceed now. What I'm going to simply do is to showcase, like the front end. Remember, our communication should be coming from the front end. Ideally, it should be coming from the front end. We did not show that here. We're simply pointing to like the backend services directly. But of course, users, communicates to the front end, and then the front end. So the DNX right here will be pointing to a single. I mean, it can be a front end that can scale, right? It can be a front end that have like horizontal scaling. So you can choose to have your front end deployed either on a managed service or, um, let's say you have a front end deployed to uh, like an EC2, like a virtual machine, right? But yeah, I mean, that's what we're going to be doing. So what I'm simply going to do right now is to just, let's move this down a bit. All right, and I'm going to move this alongside arrow just like this. Okay, all right, so this is what I'm going to do. Instead, I'm going to have the load balancer right here, and I'm going to be having the front end. Okay, so what I'm trying to show is, of course, we want to be, we can choose to have like the front end, and then the front end will then call the backend services via a gateway, right? Why do we want to go via a gateway? We probably want to use a gateway so that we don't have like this backend base URLs exposed to the front end. So the front end goes through the gateway, and then the gateway will then proceed to forward that request. That is an option that we can have, right? And that's a good option. I mean, obviously it's a good option. But now I'm beginning to think of a different thing that we could actually have. So what I'm looking at here, let's see. All right. So let's say we have like an API gateway, right? Let me see. Let's see. I want to basically look at the communication here, because we already have that load balancer, right? So all right. So say we have that API gateway. Okay. Okay. Okay, okay. So I think I get what the best option we should have here. So basically, we can have like that load balancer, right? And that load balancer would probably Is that really necessary for this use case? Okay, so this is what I'm looking at right now. If we're currently using the load balancer already, to balance the traffic, I'm trying to ask myself, um, I think the gateway would still be, very good, right? Let's see. Um, yeah, yeah. Okay, let's stick with the load balancer for now. I'm trying to see why I should or why we should spend. Okay, so we have the user, makes a request, of course, through the DNS, it goes straight into the load balancer. The load balancer balances that. Okay, all right. So let's try to showcase, the communication between the front end and the back end. Um, I want to make sure that if we're balancing the requests on the front end, right? Let's say we have like multiple front end servers and we're balancing the request on the front end. We'll definitely, get a different load balancer, that would accept the request, from the front end then to the back end, right? So we're going to have some sort of extension here. If you understand, if you don't get what I mean, let me show you what I'm talking about. Okay, so basically we have these guys. I'm simply going to maybe take this off first. Take this guy off. All right. And just to save some space, I'm going to do this. So let's change, the direction of things here. So you have that DNS. Okay. All right. So let's say we have a front end. Let's say we have a front end application. So let's call it the front. Let's call it the React app. So React front end. All right, so let's just say we have two React frontend, our application running on EC2, for example, or some sort of virtual machine. It can be on Azure, it can be on any cloud service. So we have frontend 2, we have frontend 1, or it can be like frontend and maybe like some sort of replica server, right? But yeah, maybe that is not, you can just keep it as React frontend, or UI service makes even more sense. So UI service, let's not tie this to a specific technology. All right, so we have like a UI service, and we have some sort of load balancing, on the UI service as well, right? So we have sort of load balancing. So let's say we have some sort of load balancing UI service. Okay, so now this is the communication flow, right? DNS to that load balancer, then of course the load balancer then sends that request this way. So you come here, right? You come here. So let's see. Okay, so, we just have two services for now. And now these guys simply want to communicate to the backend and they decide to go, via, of course, this load balancer. So let's go to style, make this straight. Nice. Okay. So this same thing here. Of course, make this straight here. Okay, good. All right. So in order to explain what you're seeing here, we basically decided to first set up a load balancer for the UI service because we have two UI services, right? And then both UI services, communicate with the backend by sending the request traffic or the request into this load balancer that then balances the load across multiple services that we have, the user service, the profile service. Remember that these are replicas, right? Maybe to show that replication stuff here, I'll just use this arrow, simple. Yeah, this should be none. Put maybe let's make it dotted, right? We'd have to explain better. All right. So let's do the same thing. Come on. Let's just, can I just move this? I'm gonna move this. Come on. All right, so I'm just going to move this from here, just to show that replication. So Control C, V. All right. Okay. Of course, I can make this touch here, and of course, yeah. All right. So now we are showing that replication here. Okay, so let me check the chat to see if we have more messages before I move on. We've been able to map out like the services and of course the communication happening via the message broker right here. Okay, so if you have any questions regarding the communication on the message broker end, yeah, feel free to ask your questions, and I'll quickly take them before I move on to the next, yeah, to the next thing here. Okay, have any questions? Okay, so let me check the chat to see if we have any questions in the chat already. Hi, Moses. Okay, so we need two load balancers for the front end. The front end will come before, sorry, we need two load balancers, or the front end will come before the only load balancer. Oh, yeah, yeah. So that's what I just said earlier. So basically, you can have one UI service, right? You can have one UI service sitting on the server that can scale properly, right? So on the server, you can set up some sort of, scaling if you want to. You can do, um, you can basically do like horizontal scaling, right? If that is what you want to do, you can basically do horizontal scaling here. So this is what I'm trying to say. If you know that you probably don't need this, so this is what you just described, which is very fine, right? I'm looking at the fact that we can actually have a request come through like a different. Remember, initially I wanted to put in some sort of gateway, right? I wanted to put in some sort of gateway, like an API gateway. So we can choose to configure the API gateway to do some certain operations, right? Now, if we choose to go that route, which is very perfect as well, that is what I wanted to even do the first time. So we can actually have this, right? And then we'll make sure that this has yeah, horizontal scaling enabled. Let's just say enabled. Okay, so the idea is this is kind of like a single server, maybe like a React, front-end application. You want to make sure that this application is able to like, scale based on the traffic. Of course, it's a front-end app, but that does not mean, the server. That does not mean a fixed server can handle this. If you are using a managed service, of course, that also makes sense because scaling this will be easier for you, right? Maybe you're running this on like AWS. Beanstalk, for example, right? But if you're not using a managed service, then of course you probably want to say, okay, I have two servers, and I can simply load balance across both servers where my request will be going to when I try to access the front end, right? So when a request comes in, let's use a load balancer to say to manage the target, right? So it can either come into this server A or server B, but at the end of the day, you're accessing the same front end. Is that clear, Idris? So this is fine, right? This is fine. And to avoid complexity, this is fine. Idris, I don't know if you understand me, but if you have any questions, please drop it in the chat. All right, so this is fine. Right. Okay, so the next thing I would want to just show here is, say we're talking about a social media app. Now, remember I mentioned something earlier. When you're looking at the post service, let's say a user is sending a post, for example. That post probably contains, yeah, some sort of you want to manage storage. Okay, so I'm going to do something here. I'm going to reduce this so we can have some space to manage storage. All right, so for storage, let's see, what am I going to use here? Let's just use one of these icons for storage. I think I can just go with, yeah, I can just go with the regular, let's go with this. All right, so for storage, I'm simply going to use, I don't know why I keep could not get a very good, okay, let's use a bucket. All right, so for storage, I'm going to use a bucket to show that storage. And now for storage, I can be using S3, I can be using, uh, let's just call this storage. Okay, so now for storage, let's go back to the text. I just want to make sure this is okay. All right, so for the storage here, I can basically connect, um yeah, I can basically connect these services, right? I'm going to connect from the container as well, right? The container here is basically referencing like both services to avoid having multiple arrows, coming from here. So I'm going to connect these services. So let's just have this arrow point down here. Okay. All right, so let's use a straight line. All right, I'm going to duplicate this. Okay. All right, so what we have here right now is storage, and when I mean storage, we're simply referring to like files, images, right? Images. So let's just add some text here. So images, video content, right? Um, all right. So if you want to save images and video content while looking at the social media app, so definitely you want to do filtering, right? To avoid maybe having some sort of images and videos that might not. I mean, maybe it's something that you might not want to have, right? Uh, Very possible. Okay. So if that is the case, so we might have some filtering. So let's just put this in here. Remember, I think I skipped one item, which is the line that should come from the profile when updating profile. Okay, so user basically would not have images. So instead, I would just communicate to this guy, right? Let's just communicate to this guy. I'm going to put this. I'll be right here. Let's see. Okay. All right. So I'm going to quickly throw in. Let me see if I can search for a filter. So data filtering. All right, I'm going to throw in data filtering in here. That is not the way I want it to show, but let's just keep it here. So we're going to throw in data filtering because we're trying to filter, and make sure we remove, images and videos that you might not want to have on this. Come on, can I rotate this? Okay, so let's call this content filter, right? I'm going to drop that as well. I mean, there are platforms that you can basically use for this. I'm not, giving specific names, so content filter. I'm just trying to show, from the high level, we want to make sure that we're able to set up filtering. And what you're doing here is if the item is unable to, go through the content filter, I mean, if you have some messages that says, oh, this is not, right for our network, we don't want this going into our network. And of course, it means you would definitely want to, you know, delete that particular post. If it's a post, right, you want to delete it. If it's a profile picture upload, then of course that would not save. Okay, so that's the point here. We're basically, having this, right? The storage store the images and videos. All right, and of course from this you can also choose to do things like click stream analysis if you want to do that. If you want to monitor like the activities of the users, you might then decide to set up some sort of analytics, right? And yeah, so basically if you're setting up analytics, let's see analytics. Of course, I don't want to use specific services here. It's yeah. I mean, I can't really get specific icons that I might love to use. So, which is why. So this is stream analytics job. Okay, so this is basically. I think this can actually work, even though this is coming from Azure. We are not really referring to using Azure services exactly, right? But we can basically, set up some sort of, click stream analysis, right? So we can decide to just use service for this. So this is all right. So let's just say we're doing this, from like we're trying to track the posts, that a particular user is interested in. Okay, so we can be doing that using that service, and at the end of the day, that service would, probably also communicate with some sort of, storage, right? So the data we're storing from there can be like a JSON data, right? And then we can choose to save that JSON data into like the S3 storage. And at the end of the day, we can choose to have S3. We can choose to have a service that can pick up that data from S3 and push it into some sort of, big data analytics platform, right? I'm simply going to move that text. to the top so that we can have right. Okay. So this is it. Okay, good. So after pushing this in here, we want to make sure that I mean, this is the point where you can even decide to say, I don't want to use a single storage. I want to have third party, or I want to have a different, storage bucket for this, right? Which is not bad, right? So you can simply call that, analytics storage or something, analytics storage, analytics storage. Let me zoom in on this. I'm going to stop very soon. I mean, there's so many things you can possibly look into, but because of time, I'm just going to focus on this. Stop here. Let's have this guy. All right. Come on. Okay. So yeah. All right. And then this guy right here points to this. That makes sense. Okay. So we want to connect this to, like, maybe Hadoop, right? So if you don't know Hadoop, Hadoop can be used for, let's just use this. So Hadoop is basically a big data analytics platform. All right, so let's call this Hadoop. We're putting this into our Hadoop cluster. All right. And yeah, so one thing you should know is, right now you see we have from the clickstream analysis going straight into a storage. This is the point where you can also say, I want this particular data to go to some other channel apart from just that storage. So you can choose to implement something like Kafka, right? Or you can also leverage this broker, but I would prefer to go the route of Kafka, because we're talking about streaming here, right? So I can choose to go the route of Kafka where I don't necessarily need to go with this, right? So I can be pushing my data into Kafka. And of course, if I am putting my data into Kafka, let's use manage streaming for Kafka. This icon is not bad, even though that is not what I would have loved to use. But let's just keep it this way. So we have Kafka, right? Um, Another option that you can use, and I usually advise people to go with, is Event Hub, right? So one amazing thing about using Event Hub is you can actually have multiple clusters, set up for this. You can choose to have, yeah. So like this is the icon I'm talking about. So I can choose to go with Event Hub, which is a Microsoft service, but then I can configure this to, by default, it actually supports Kafka. So I don't need to really do any, serious configuration. I mean, it's just there, by default. Okay. So if my data comes into this Event Hub, I can then choose to, push that data into an Hadoop cluster, right? And from there, I can also choose to do some sort of, processing. Maybe, yeah, I can do some processing using Apache Spark, right? You want to do some processing. You want to make sure that the data that comes in is eventually, I mean, you want to make sure you have like intelligent data flow. You want to be able to come back and say, okay, this is what this user is currently doing. This user prefers this kind of data. Let us recommend this kind of. So you can be using Apache Spark, to perform that kind of, job, right, on the background. So let's just have this happen here. Then maybe at the end of the day, you want to store, some of the final data into like a warehouse, right? So we can just have that enter a data warehouse, right? Of course, we've gone beyond the microservice scope, but this is what we have for the microservice scope already. And if you want to do some additional things like checking for business intelligence, of course, you can do that as well. Business intelligence. That's for the business team, basically. So, picking up data from the warehouse, right? So let's just have this. Okay. All right. So I'm just going to I'm going to check the chat now to see if I have any questions. All right, so this is just going to perform. So yeah, when Apache Spark performs those operations, I mean, it can be saved back into like a different partition, in your Hadoop cluster. So we can basically save that into like a different partition, right? Let us see, what do we have here? Okay, I'm just going to leave that part for now. Remember, we've actually set up like the content filter. We've done some sort of, analytics. We can decide to go the route of, also setting up some kind of compression, right? When images are being saved, we want to compress them. When videos are being saved, we want to compress them. If we're going to be connecting like, mobile, the mobile, we can choose to also say, okay, the data from the mobile, should probably flow through a CDN, right? Whether from the mobile or the web, we can choose to introduce a CDN. As you can see, we don't have, a CDN, which is not very good. So we can choose to have a CDN, from our web browser. You can connect like the web browser or the mobile apps, and then that's, we have a CDN sitting in between, right, into like the storage. Okay, so fetching some of this data, right, it can be coming from here. So we can actually introduce CDN. So let's call this content delivery network. Okay, and then this can actually come from here. So let's have this. All right, and this is communicating with our storage, so that we can actually have some of these things, inside. We don't need to always make, round trip calls to the storage every single time. All right. So I believe this is fine. The major thing here is that you are seeing how we are able to use, this load balancer to communicate across, multiple services. So if you're calling the user service, whether it's the profile service, whether it's the, post service, and yeah, these services are also communicating with these other guys. For the profile, we have our assumption to say this user can be storing like, profile image, right? Which is why, we have this flow right here. In order to even make this, sometimes you just have to make sure like, your diagram looks smooth enough, right? And easy to understand instead of having all these, lines, crazy lines moving here and there. I can actually decide to go the route of switching this up, calling this my user service, right? And of course, this is for this profile. Makes things even simpler for us. Okay, so yeah, I mean the next thing I would want to do if I'm actually designing this, if I'm trying to use a specific cloud for most of these operations, I can simply start replacing some of these services with cloud services, right? But I'm not going to do that because we're already out of time. But yeah, I mean in the next session we'll probably design an architecture specifically focusing on a cloud service, and we can go as far as talk about traffic, talk about like the user size, and why we would probably need to deploy this with a different pattern, maybe using Kubernetes, right? To manage our clusters, to manage our services, to manage the networking. Yeah, that would be a very interesting use case to consider. So I hope you enjoyed this session. Let me check the chat. I will answer a few questions, and I'll probably see you in the next call after that. So something like filtering news and yeah, exactly. That's what I was referring to. So thank you, Idris, Moses. Um, yeah, Moses. I just noticed you were not on the stage initially, but I hope you can hear me now, Moses. Hi, Moses. Can you hear me?
Oh, yes, I can.
All right, all right.
Yes, I
So
can hear you.
yeah, I think you joined in late, so probably I'll be expecting you in the next one, so we can actually walk through the system design session together. Okay.
Sure.
All
Glad
right.
that.
All right. So have a wonderful evening, guys. Thanks for joining in, and I'll see you next time. Bye.
Yeah. Thank you. Thank you, everyone.